something called reactive extensions. And fundamentally, it's a way to do things that's not necessarily a framework, but you have a bunch of framework in different languages. You actually have a family of frameworks, but this is the one I like. So it's this one.
Reactive X.
Yeah, you have an RX framework for Ruby, for .NET, for Java, for Swift, for Clojure, for Scala, for a bunch of things. I guess where it's like really cool, it's the ones here. Like RX Java is definitely big on Android. This one is big in JavaScript. Angular uses it. Don't know about .NET, but I can imagine that there's a bunch of it, and it's really nice in Swift. A development that Apple has done recently is they have introduced something called Combine, which is like very, very forward thinking from Apple, but it's essentially RX. So it's the same idea. If you ever like start doing iOS, Combine is essentially RX. Now, whether we should be using RX or Combine is a different question, but I'm not like iOS 13 compliant yet, so I'm using RX. I might change in the future. Cool. So,
okay,
what is it about? Simplifying it a lot, it gives you a type called observable, and it's a container type. So it's say an observable of int or an observable string, and it represents a stream of values that can change over time. And the protocol is that you get changes with this next event. So you can get an event next with a new value. And then finally, you either get an error event that contains an error or a completed event. So that's the protocol. You get like a bunch of nexts, and then you get either an error or a completed event. Not every observable needs to be completed, and not every observable needs to emit new values. There are use cases for either, really. But we can model a lot of things with that idea. So, for example, we can model a network call that way. A network call would be, it waits for a while and then emits the result from the network call and then emits completed. Or alternatively, it just emits an error.
Yeah.
You can model, say, like a list of things. For example, you can model this list here as a observable of pull requests. No, sorry, that's repositories. And initially it would emit the list it fetched from the network, and then every time I change something, for example, press the star here, it would re-emit the list again, but with the value changed.
So only with the value changed, or the whole list?
It would re-emit the whole list.
Okay.
But you re-render the whole thing, and then you're fine. You can model a lot of things this way. So why do you do it? You get two things. One of them is you get a subscription capability. So some code can give you an observable for your network request, and you can subscribe to it. And subscribing to it means I want to be notified about changes. And this would allow you to decouple business logic from UI very well.
Yeah, of course. So it's kind of an event in a way.
Yeah. Another reason you want to use it is because you get a bunch of combinators. So you can map an observable to a different observable, or you can even do fancier stuff. For example, you can make single network requests, and this if you did not have GraphQL, to say fetch the list of repositories I have access to. So let's say this returns me an observable from repositories. Makes a single REST request, and then I get like some JSON. And then I can flat map this to essentially a list of new requests, each of them observable. That would make a request for each repository to get the pull requests, if it makes sense. So one for each repository. And then finally, I can, depending on how you want to go with it, reduce the whole thing to, say, like a hash that maps a repository to an array of pull requests. So I start with a single call. As soon as that completes, I fire multiple calls, one for each pull request, and then I combine the result together.
Okay.
And every time there's an error, that error is going to get traced down to the bottom. So this like final observable is going to emit an error instead, and then I can deal with the error. So don't worry if you don't get the detail right now, you're going to see it in action. But fundamentally, it's very simple to promise from the JavaScript world. So, like promise is something that eventually completes or errors out. And if it completes, it gives you a result, and you can map it additionally to some other promises or just transform them. The only difference is that an observable can emit many times, a promise can emit only once.
Yeah.
So yeah, I mean, like observables are the big brothers of promises. Cool, so that's about it.
Okay, so let's see it in action.